which is to delete at index. I think so. Write a function that will delete node at index of a list. So at a particular index, it's going to remove one node, right? So it's going to be basically all those things that we've done so in the past. We're just going to add some flavor to it. So the first thing they say, where index is the blah blah blah, returns 1 if successful, minus 1 if failed. Alright, so we'll do our 10 main.c, right? Okay, so copy this guy. So vi my 10 main.c, paste it. Alright, so what we'll do next is let me touch the file name. So up, and it's called 10 delete node int, right? So I'll copy this guy and paste it. Okay, okay, good. And then I'll copy the prototype. So where's it? Yeah, good. So I'll copy this guy and copy, and then I'll paste it in my lists. Insert. Good. So far so good. Alright, so we are almost done with that. 10, what's it called? 10 delete. Okay, and insert and home, and we're going to include our main, our lists .h, and then we're gonna document this guy. So it's going to delete node integer at index, right, at a particular index. So this one is to delete a node of a list at a particular index, right? And then this guy is going to have the head, which is going to point this. The head is going to be pointer, right? Pointer to the beginning of the list, right? And then we have index, right, which is the index of the node to be freed. Right, and then we are going to have the return value. It's going to return 1 if successful, and minus 1 if not, right? Good. So for this one we have unsigned int index, so we are going to have unsigned int as well, but this one is just for iteration, so let's call it I. Alright, so we have our list integer underscore c for temporary, right? And then we're gonna have our list integer underscore t for the node, right, to be deleted. So it's because the node would already exist, so no need of creating node for it, right? So we just want to remove it out of it. So we'll give our temporary to head, right? So add temporary head, right? So we'll say if our head, if the head is equal to null, itself is equal to null, then it should return -1. -1. Alright, so the next thing is we're going to have our for loop to iterate through and delete. So as far as I equals to 0, right, and then I is less than index -1. I think I didn't explain this -1 the other time. Okay, I is less than, and tempt or TMP is not equal to null, and index is not equal to 0. Okay, just like the other one we did, and then I plus plus, right? Good. So at this point, as far as it's not 0, then we will continue increasing our TMP equals to add arrow next until you get to that point where we are going to, right? So that's what we're going to do. So we'll say if our TMP is now equal to null, so it means it has gotten there and it hasn't reached, right? So if our TMP give us null, then it should return -1 as well, showing that you've gone past your boundary, right? You've not gotten to that point before. So if you watch the previous video, I explained this, right? So what else? So we'll say if our index 2 is 0, so it means that we are going to delete the first one, right? So if our index is 0, so we want to delete the first one, right? So we'll say our node will equals to TMP next. Okay, our node equals to TMP next. Okay, so what we did here is we created a node, right, and then it's equal to TMP next. That is, if it's just one, this is our TMP, right? So node is equal to TMP next. So kinda we are skipping this guy, leaving it alone, right, and then giving it. Okay, so what we are doing basically for that part is that we are actually assigning this guy to node, right? We are giving this guy to node. Okay, so since TMP is temporary, holding this guy, serving as head, we are giving this address to node, address of this guy, right, to node. Okay, so node is holding this guy now. Alright, so since it's holding that guy, we can then free TMP because we don't need it again. Sorry, free would have the bracket close to each other. TMP, oh sorry, TMP, and then that will be all. And then we'll have our head to be equal to node now. So our head will now be pointing to node. Okay, so that will be it. So because this is node now, and then our head is not, we'll give it beside node, so TMP has been freed and is free to go. Deleted it. Alright, so freeing is like deleting. We've removed the stuff, the memory, right, because we don't have a delete button. Alright, so else, I think we just add this else, and like I did before, let me just add this return down. It should return 1 at the end, right? So else would finish the job for us. So before that, we're gonna have an if statement and say if our TMP next itself is equal to null, Okay, so if it is the last one, so the node will equal to tmp next, right? So I think this one will deal with when it is the last one, right? So if this is the last one, our node will be this, right? And else we have just one line of code, so we can use it. So else node would equal to tmp next, and it will free tmp next. And then tmp next, then will then equal to node. Let's see if this guy works first. Let me see. Okay, let's see. Is this guy long enough to use Betty? Let's see. 10 delete. Spaces preferred around that dash at line 18. Okay. And which dash? And which dash? I can't see it. I didn't pay attention to it. Okay, for I equals 0, I use this index. Okay. I think this is it. Okay, good. So let's check the code. We have one error. Okay, so that place we're going to put brackets for that guy. Line 13, right? Line 13. So tmp equals to add next. We have something like that in line 13. Line 19 rather. Line 19. Okay, tmp equals to add next. No, it is just the add now. So it's not the point, it's the, let me see. Okay, tmp next. This guy is supposed to be tmp next, not add next. Because let me use tmp first. Tmp add is still kind of the same, but let's, because they are together, but I think we've moved tmp somewhere before. So let me check now. Oh, not this one. Compilation. Okay, it compiled. Oh, we have some errors, right? Because I'm not sure this is how it looks like. Is this how it looks like? 1, 2, 4 dash dash dash. Let me see. We have dash 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 dash. Okay, we do. Alright, 1, 2. Oh, nice. So let's git add comments, and then we say delete a node at a specific index in a let us test our code. Time is going, running out of time. Okay, so we still have 4 more to go. If this worked. Oh, nice, great. So this one is write a function that will reverse a list. This guy is kind of complicated, but not complicated. And then it said it should return a pointer to the first node of the reverse list, right? And then you're not allowed to use more than one loop. You can use malloc, and then you can only have 2 variables in your functions. Okay, bless me. So we'll do 100 main.c. I think this is advanced already. Okay, so we'll copy. So vi 100 main.c, right? And then I'll paste this guy. I'll exit this guy, and then not yet. Bit down. 100 reverse. So it's going to reverse it. So let me touch it, right? And then let me copy this guy. We're gonna copy this guy. So I'm gonna vi this guy. Oh, sorry. I'm going to vi my list. Right, I'm going to paste this guy. We still have more. Good. So I'm going to vi my 100 reverse. Paste this guy. Insert, delete. So I'm going to include my lists.each. Right. What's going on? Why is it now? Why is this thing now? Let me see. 100 reverse.c. Okay. Okay, it's working. Sorry, I was thinking we have an integer here or something, because we're supposed to have a color, so I thought I didn't save it with .c, but it's 100 reverse.c, so it's correct. All right, so the next thing, insert mode, and then let's document it. And this one is to reverse list int underscore t, right? Is it list int, just list int? Okay, so this one is to reverse a singly linked list. Alright, and then we have a pointer to the head, though it give us double pointer so that we'll be able to modify the head itself. So pointer to the head, let me just put it that way, and then return a pointer to the first element. Of the reversed list. Because we're going to have the last one will be the first, and then the first will be the last, and that's what we're going to do. And then end it. Right? And well, we now have this. So we can't have more than 2 variables. So we'll have the first list int underscore t, which will be our temporary tmp. And then we have another one, list int underscore t, and then that one we'll call it a new temporary. So we need 2 kind of pointers to iterate through this guy, right? So we'll say if our head, normally, that is the normal head, is equal to null, right? And also the list itself is equal to null, right? It should return null. Return null. Okay. Then we have TMP. TMP is head, right? So TMP is equal to head. So we have our head will now be TMP next. This part is not really necessary, and this TMP, I think null. So I want someone to try this guy with null and see if it's gonna work, right? But I think we still need to pass head to it. I'm not sure. I think TMP has to be null there. But anyway, let's continue. So this part is not I'm not sure of the I don't want to waste time because I would have tested it, because I don't have time to do all this stuff, and it's really hurting me, because you learn more when you make a lot of mistake. Actually, when you don't have any compilation errors, you obviously won't learn a lot. So as far as our head is not equal to null, so we want to iterate through, right? So while iterating through, we'll have this, right? And I will say, I will explain what happens in this code, right? So we'll say new TMP, right, is equal to because of this guy, we'll say on the list next. Okay, and then the list next again is equal to TMP. So and then TMP would equal to the list itself. So we have another condition: if new underscore, this guy too is not really that necessary, is equal to null, because at the end it's going to be equal to null. Is equal to null, return head. Return head. So we might just be having some one output error probably if we didn't include it. Sorry. Return head. Let's put return head, and then you can say head is equal to new underscore TMP. Okay, I'll explain, just don't worry. So we have if, which is the last one, our head is equal to null. Why? If our head is equal to null, so we are reversing, right? So if our head equals to null, head will then equal to TMP. Head will equal to TMP, and is going to return it. It's going to return it. If not, it should return null. So I think with this we should be good. So basically we are trying to reverse, right? So these are the main points here. So if head is null, right, so it means reversal will not be needed, right? So we are just going to return the head, because if head is pointing to this null directly, it means there's no content in it, right? So reversing it is still not significant, right? So that's what this guy does. So for this guy, we're going to do something in which, okay, you said new, where is it, new TMP, where is it, new TMP, new TMP, is it new TMP that I wrote? New TMP, yes, I think, okay, yeah, it is, yeah. So new TMP, so where is it, okay, up to here. So new TMP, right, we gave it add next, right here. So we are going to go through the list, right? 1 2 3 blah blah blah, right? So it's going to go through. So at the first time it is not null, right? This guy is not null. So what it does is new TMP, which is nothing before, right, is equal to add next. So new TMP is already pointing to this guy, right? New temporary is pointing to this guy. Add is still here, which is connected to everybody, but new is pointing to this guy, right? So what we do is, okay, we've done that, right? So if you want to change reverse, one thing is that all, aside them rearranging, the pointer of each would change as well. For example, this one pointer will turn to null, right, if you are reversing it, right? So this one, instead of pointing to this guy, it will be pointing to the guy in front. I don't know, you can do the math, write it down, and then you would be able to see that all the links would change as well as the position. Okay, so that's what we will do for consecutively. All right, so add next is now temporary, so we are saving the add next as well to temporary, right? So we are swapping one, also change swapping the add next, we are saving it there. Okay, so since it contain address, so this one there, so we have our TMP now, which is now equal to, no, we are giving, sorry, we are giving TMP to add next, right? Our temporary to add next, right? So our temporary 2 would then point to this add next, right? Or our add next would point to temporary. Okay, so and then what else, let me see. So ignore this guy for now, and then say if this one would run if when it is equal to null. So add equals to new temp, so we'll update our add to be equal to this guy, right? So basically I might just drop a kind of explanation because I'm running out of time under the description, right? I'm going to drop it. Please, if you are saying this, just remind me for this task I should drop the explanation, right? Or if I have time, I'm going to create a separate video. I think I should have on Sunday. All right, so all these promises I hope I fulfill them because no time. So let me just test it first before I even start my jargons. All right, so what do we want to do? We want to Betty 100 delete. Hey, this thing has frozen now. The network. Okay, so CBALX low level OX13. So want to Betty 100 delete. Is it delete? 100, what are we doing? Reverse. We're reversing. Okay, good. So let us compile. Okay. Papa. Okay, I'm going to make sure I post that. So we have 0 to 1, 2, 4, and then he printed it in reverse. I think that should be it. So let me just git add, no need of checking, git commit, and then this one say reverse is simply linked list. I'm going to git push it. Alright, if you check it, you think we should have the same thing. Yes. So check our code. So it's almost getting time to. So tax. What's it called? Tax. So we are good. So tax 11 and so tax 12 and 13. Tax 12 and 13. I wrote the explanation somewhere, so I'm just going to explain that to you through the jotting I did. But tax, the last tax, I think that's much more simpler. It's just to check it through a kind of loop. If there's a loop into it, that is what they call a circular linked list, right? So if it is a circular linked list, and then we use to pointer to check that one. But before that, let's just go through this guy. So this one is to write a function that will print a list, right? A linked list, right? It's going to print it out. So we have all this blah blah blah. The function can print list with a loop. So if it's a circular linked list, like I was explaining, it's going to print it out. You should go through the list only once, right? If the function, so this one is not just printing a loop, it has much more dynamics in it, right? If the function for you should have 98 blah 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 blah, right? So it has much more things to do, right? And then so that's that. So let's just create 101 main.c. So I would copy it. I would just probably read that explanation that I jotted down out, because I didn't have time to actually too much digest it. So vi 101, right? 101 dash main.c. So do this, paste it, right? Time is going, and then I would post I'll paste this guy somewhere around here. Sorry, I'll touch this guy, and then I'll get my prototype, right? Okay, so after that I'm gonna vi my list .h, right? And then I'm going to vi my 101 print, paste this guy there, and then boom, and then I'm going to include my lists .h. So I'm going to include my list.h, right? I'm going to free the list. I'm going to create two functions, right? A free list, right? So let me call this one free list d for d. All right, so I'm going to free list d, and then this one is to free a linked list, right? Okay, it's going to have an head pointer, head of a list. I'm going to return no return. So we'll say void, right? So it's no return. Free underscore list d, and then going to have an head pointer, and the head pointer is for list p_t. Well, let me call it list p list t underscore t. Okay. Or what have we been using? List int now. Okay. So okay, I think I can use that. So we'll say list d underscore t. We have a temporary. We're trying to free list, right? List d underscore t. We have the current. Okay, so temporary and current. We'll say if our head is equal to not equal to null, not equal to null, not equal to null, then I want to update something. Then we'll say our current should equal to our head, right? Our current should become head. So if it is not null, right? If our head is not null, then the current, right? The current, we are giving it the value of head, right? So we have a while loop and something like this. Okay, so we'll say while our temporary is equal to current, it's the same thing, but I'm just trying to use the temporary, right? It's still saying while current, right? While current is not equal to null. So here I'm initializing and also still giving that condition. So you can still say while current is not equal to null. So while that current is not null, because we've passed, is still saying that while head is not null, that we're still doing here. Okay, it's the same thing, but here we've just given it to current and from current to temporary, right? So while it is not null, right? So our current will equal to current next. That is, we are moving current ahead, and then we are going to free the previous guy. So we're going to free temporary, right? So temporary. I think I didn't use temp here. Temporary, right? Temp. So we'll free that, and then we'll come here and say our head then will equal to null. Okay, so I think this should free it, and then we'll come here and declare this guy and document it rather. So it's to print list int safe, right? So it's to print this, and then we say print a linked list. I'm going to type out the explanation also for this one and the next one, and then the final one I would explain that to you because of time. But apart from typing out, I'll try and explain the little I can. So the top, this one is just to free the list. We can't free inside this page because it's going to be too long, right? That's why we split it. So we are going to have our head, right, which is the pointer to the list, right? And what else should we have? We have our return, which is the number of nodes in the list. So we're getting there. So in order not to waste time, let me get into it. So we have our size underscore t, because that's our return type, and then we have our notes. We have notes. I'm feeling sleepy already. I have to be fast because it's already if I start saying rush. So we have our list t underscore t, list t underscore t, pointer to slash hptr, comma, name. List G, I think it's list speed I'm supposed to use, I'm not sure, so I don't want to cause any commotion. Let me just use it here. But you can test with D. I'm not sure if this is what is defined in the type def, but I think it's not, but just list P. I don't want to be correcting. Okay. Name, comma, and then we have one more. Add new and add. That's that. So we have our age pointer, right? Our head pointer equals to null. Initialize it to null. I will say while this end is not equal to null. What should we do here? So I'll create this. I'll do that, and new is equal to malloc, and then we have our size of lisp underscore t, size of lisp underscore t, in that here. So if our new is equal to null, it should exit 98. Okay, new e is equal to the void pointer to head. So we are kind of dereferencing, and the new next, our new next is then equal to our header pointer, and then the next thing is our header pointer will equal to new, and then we have our add function to be equal to header pointer. Then we have another value which we add next, and then as far as that one is not equal to null, we have another guy like this. As far as that is not equal to null, so our add will equal to add next. So if our head is equal to add p, then this, then print the value out for us. So print f the value, which will be this in brackets, and change this and the pointer using p the value using d and the new line, and then comma, and then we'll create the head address of the head, and also a value of the head, but we have to dereference the head here to void pointer. And then we'll end it here, and then we'll free, we'll call that free function free lis tp, I guess, lis tp. Alright, we'll call it, and then we'll pass the address of hptr, and then we'll say return endnotes. Our endnote is equals to 0 from beginning, so we're going to return endnotes. And then what else? I think that's that for this. Then we'll come here and then we'll print f. We'll print something out. And then we'll have our head to be head next. And endnotes plus. So this place we're going to print something out, and also come down here and we'll free again, free underscore lispt, right, gspt sp, and then address again, the address of h pointer, and then we'll return the head nodes and number, and it's number of nodes. So we return the number of nodes. For this place we're gonna have this first, and then we'll have this, and then we'll have our percentage b space percentage d new line. So just like we had at the top, we'll have here too. So it's going to be void pointer to head, and then add the data. Right, so this is basically it. And in explanation, let me see where I can start from. So say so after this guy does a free function, right? So this one is responsible for printing the element of the linked list. So it will ensure that it handles self-referential loops to avoid infinite printing, right? Because so if there's any loop, it's going to avoid it so that it won't just be running infinitely. So it will take a pointer to the head of the linked list, which is the head, right? So which is this one, right? So as input, and it returns the number of nodes in the list, right? It will return the number of nodes in the list, which is this size t, right? So So it will start by declaring. We declare three variables here, which is which this guy is then initialized to null, right? So this guy is initialized to null, and it will be used to maintain a stack of node to track visited nodes during the transversal. So this pointer is used to track visited node during the transversal. Okay, so the function uses a while loop, right? We use a while loop to transverse the linked list. Okay, so we use a while loop to transverse the linked list. So inside the loop, a new node new is created, right? So we created this new, this is it, we allocated kind of memory for it, and then we created it. So we said if the new node is null, right, it should return exit 98. Okay, so I think you understand to that point, right? Let's see. Okay, so the new node is then added to the HPTR, right? Where is it? New, yeah. So we have the new dash p. Is that what we should have? Yes. Okay, well, so the thing is, I would drop the little explanation from this point to the end, or probably the full explanation. I'm going to drop it in the comment section just not to waste my time, because I haven't slept yet. So Betty 101 print. Okay. We have some errors. Error at space required before the, so 5563. So 5563. Which other one? 7 and 40. What happened in 40 first? Parenthesis. In 40. Yeah, I saw it before, but my mind skipped it. Exit 90. Sorry. 98. And then full bar should be full bar. Let's see again. Number 7. 1, 2, 3, 4, 5, 6, 7. Right? Should it be here? Let me repeat it. Oh my god, I hope this thing is not frozen. Escape now. I'm pressing the escape button and it's not working. Okay, it's working back. Let me repeat it. Okay, full bar should be full bar. Line 7. Okay, so drop 9 7. So what do we have here? Oh, sorry. I think this is the issue. They're giving me example. So let's get it. Okay, good. So we are good with that. And what do we do next? We must singly linked list this, right? So I'll drop the explanation just not to waste time. Let's put this one compile. Oh, sorry. I want to overcopy. This is when you're rushing. Okay, so I'll delete all this. So we have so many errors. Alright, so let's try and fix them. Free list integer. Free list integer. Okay, inclusive declaration of function. Alright, no. Okay, I think that's why we have all this rubbish. Wait. Yeah, I was hoping this guy should be list int underscore t. In function print list. Let me see. You know what? Maybe I'm just gonna pause this guy so that we don't waste time and do the last three separate. Or let me see if I can still quickly sort it, because I'm feeling so sleepy. I can't even fix any errors like this. Alright, so unknown type size. Oh, look at me. I mistyped here. Okay, let me see if I can still sort something out. Okay, vi. Okay. Let's see. So it should be size. Let me just use this one. This one should be list int underscore t, I guess. List int. Let me use list int for it. Alright, so list int. Do we have any list int here? List. So let me go up. Let me use list int underscore t. List int. Okay, we still have some errors. So if we continue to have these errors, I might just let me see. List int. This one will be changed. So many errors. So I'll just pause it and I'll fix them and then we'll continue in the last one. Okay, I've fixed that issue and I'll walk you through. So the thing is, I forgot to create the struct for that particular task, right? So let's go back. Where is it? I think it is this one. Okay, it's this guy. 12, yeah, number 12. So let's vi. So vi 10. I think 12 is 101, right? Let me see. Yeah, 101 print list. So vi 101 print list. Okay, so page up. So we have our list, right? So I change this one back to list p underscore t, p underscore t. right? So we have to create a struct for this guy, right? So I was wondering, but my mind didn't go there on time. So after I ended the video, I realized, so it's still the same code, nothing changed. So I went to my vlist.h, right? So I added the struct here, as you can see, right? So we have that p that we've been using and the next, right? Because this one is a void, so it's different from the other one, which is an int. So we can't really use this one. We have to create another one for this guy. So we call it list underscore t, and it is type def as list tp like this, right? So that's it. So did I add the, no, I didn't add it. So that would be that for that. And let me compile. I haven't compiled. So what's the name? Let me compile it. So GCC up to M. So I'll paste this guy there. I need to compile, right? So M, and then we have all this. So 1, 2, blah blah blah. Right? So declare. So git add just 1 print and my list.h because it contains the header file and the struct, right? So I'll git print and say what is the tax for this guy? Is to print list. Of node and push, right? So let's go and check. It's almost time to start having checker issue. So I don't know. I'll just try and be fast as possible. I think it should work. So in order not to waste our time, let me just wait for some seconds. If it doesn't work, we'll continue. So we'll know that it's the checker problem. Alright, so it should work. Okay, good, it worked. So let's go to the next one, which is second to the last. So for this one, we have to write a function that frees a list, right? So I've written the function, but I've not done all the necessary things. So 102, so we'll create the 102 main.c, right? So copy, so vi 102 main.c, right? I'll post it. So where's the prototype? So this time around, I'll copy this prototype. I'll paste it in my list.h. And this will be that. So I'm done with this. Where is it? Alright, so once I'm done with this, what do I do next? So we have so it said this function can free a list. You should go through the list only once. A function that frees lists with a loop, right? And then the size of the list was, so a loop basically is just when this guy, right, is not connected to null, it's connected to probably this guy, right? So it's going to loop through, right? It won't stop. Alright, so what else? So the file name is 102, so we are supposed to write the function, right? So I've written the function, so I'll just go through it a bit. Let me see. Or I'm going to just add the explanation of this one. I think I said this one and the previous one. Alright, so what I did here is we created a function 2, right? A free list p2, and we still use all those old stuff, and this one is just the old thing I did in the previous previous guy, right, to free the list. And also we then create the function, and this is the function, right? So the function is a free list according to this, right, the age and then the return. So which this one is the number of nodes. It's almost the same thing as the other one. We initialize this one to null. We created a memory for this one, exit on 98, and then we have all this, just like the other one, right? Is this, are we in the right track? Yeah, I think so. One or two. Yeah, so, and then we have this, right? And so I'm going to drop the explanation to this on the comment section. So basically this is it, and that is all for this, right? And then we have this and this. So I'll drop the explanation on the comment section. Please try and go through it. I don't want to waste my time. Let me compare and see if it works. So page one. I'm going to explain the last one to you. So I'm just going to drop this number 13 and 12 explanation on the comment section. I think I want more. You can let me know in the comment section if okay. So we've done this, right? So this is it, and then so I'll just add 102, what's it called, 10. Oh, the compare one prints with it. So 102 free and list. Right? So git add git commit. Message will be I think it's TP list. Push. So let's check that it would work. It's already check Alright, so that, and let's hope this guy works. So we've got the last one. We have just probably 2 minutes left to finish up this guy. So while this one is loading, let me copy. Okay, that's checked. Good. So the last task now. So what we do is create 103 main, right? To test 103 main. Let's see. Copy. So we have vi 103 and now main.c. So I'm supposed to extend this one. So the next thing we're gonna do is get our prototype. Right. So I'll get my prototype. Okay. This. I'll put it in my list. Sorry. This is the last one, so I'm done having that. And what else should we do? So then our file, right? And this is the last step. So 103 find loop. So this one is to find a loop, to find if there's a kind of loop in our assembly linked list, right? So if it is a circular linked list, right? That's what we want to do. So find loop in a linked list, and then the address of a node where the loop starts, or null if there is no loop. That's what it's going to return. And then you are not allowed to use this. You can only declare to maximum. So let's VI into that file and see what happens when I will find the loop. Okay. So basically, to do this, we'll declare 2 pointers, right? So pointer 1 and pointer 2. So pointer 1 point at this, right? They are going to both start together, but we are going to have one which is speeding than the other one, right? So pointer 1 would iterate through the loop, through the list, and pointer 2 would iterate through the list as well. So the difference is that pointer 2 will be going 2 steps ahead, pointer 1 will be going singly. So we are going to say pointer 2 would increase by next, right? So pointer 2 will, if you have 2 pointers, this and A and B, so we have 2 pointers A and B, right? So pointer A will be iterating like this, right? Like that. So if this thing is a circular, it will iterate from here to here to here, and then come back here, and then go here, and then go here, and then come back here. But pointer 2 would be going twice. So pointer 2 will go from here to this place directly, and from here it's going to skip this place to this place, right? And then from here it's going to come to this place. So in so doing, normally if it is not a circular, pointer 1 and pointer 2 will never meet each other, right? Because this one is going 2, and then this one is going 1, right? By the time this one gets to the end, this one will still be at the middle. But if it is circular, by the time pointer 2 goes this one, by the time it repeats like 3 times, it will meet this guy on the road. So by the time any point where they meet, once they meet, then we say that it is a circular. Alright, I don't have whiteboard to kind of explain, but it would be nice if I can do that. Probably in the next tutorials we'll be using whiteboard to explain, so it will be much easier. So basically, that's just it. I hope you understand. I don't know if I should still go on, but hey, okay, I thought this thing was frozen. So we need 2 pointers, right? So pointer 2 is pointing to it, this one is pointing to it, right? They both start at the same time. Right head and P2 and this is next, blah blah blah. So as you can see, head is P2 is now serving as the head, so they used head and P2 to iterate here, right? So head is now head next, and P2 is now P2 next. So the two of them would run through, right? So if head is equal to P2, right? So by the time head and P2 they are equal to each other, right? That is when you know that it is a single, it is a circular, right? So that's what is happening there. Okay, so if this is happening, then head is equal to previous, then as in we give that previous link to head, right? Because we want to kind of return that, right? I think so. And then previous, we'll give it the address of P2, right? And then while true, while one means true, P2 equals previous. So you go through this, I might just add one more explanation to this, but basically that's it. And let's see, P2 equals previous, while P2 next is not equal to head, and P2 blah 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 is not doing P2 equals. So these ones are just assigning and doing all the other stuff this guy has to do. Okay, so that's basically kind of it, how it works. So you can just make use of that information and try and digest the code and see. So it's morning already. So let me just quickly finish up this. So we have 0. Oh. So I think it should work. So we add it status. Okay, good. Git commit. Git commit dash n. Oh, let me just clear. And then this one will say detect. So let's see. this should work. Good. And then we're done. Alright, so see you in the next video.